Howdy, folks, and welcome to your storm chasing forecast show for Tuesday, June 23rd. I am Gabriel Harbor, and I'm joined here by junior coach Stephen Cross. Stephen, how's it going, man?
It's going.
That's it? Two
That's
words?
going. It's going.
All
I think
right, fair enough.
I say the same thing every time I say how's it going game, so I just wanted to spice it up a little
Okay, spice it
bit.
up indeed. I think you're just a little salty still from storm chasing a couple days ago. Yeah, I'm going to
Salty
make you talk
forever.
about it.
Nope. Watched my forecast yesterday. I nailed it and then missed everything. It's just how it goes.
Yeah, it's always wonderful at about 10 o'clock Eastern time to get the message in the group chat that you're quitting storm chasing and you're done with all this nonsense. So,
Yeah, but we're back at it, so that's what we're gonna go over.
Steven's not a sore loser. He's not going to grab his ball and go home, I promise. So,
Yeah.
all right, Steven, we have an interesting little setup here going on for folks today. Even though there's just one tiny 2% tornado risk, there's actually a few different targets that you and I are both interested in. We're going to hit them all one by one. So, wherever you'd like to start, do you just want to go with the main risk area?
So we'll go with the main risk area. I think, in my opinion, the main risk area is elsewhere, and that's gonna be this the Texas and Oklahoma panhandles. I think that's the main area. I wouldn't be surprised at a 2%, perhaps even a 5%. I hate to say it, but over here in this region. But another one I also expect is up here in northern Minnesota. I think that could be another storm chasing opportunity. So we're going to go over all three of these. All righty.
Hell yeah, Steven. I know the Panhandle play is one that I was actually discussing with you before we started the show, and I wasn't sure if it was one that you were going to even want to talk about. So it was pretty cool when you said that it was also sticking out to you
Yep.
today.
Yeah, I'm so convinced by it that I'm going to head all the way from St. Louis all the way over.
It looks like you've got your 500 millibar map up and ready to go, so walk us through it.
Yeah. So we have a very obvious zone of high pressure here across far southwest Texas near El Paso into northern Mexico. We've got a big old trough here going through the northern plains, central high plains. And so this is the disturbance that's going to be kicking off our severe weather threat across the plains here. So for our quote unquote main risk area right now, at least for storm chasing and tornadoes, we have a nice short wave coming through the region, and that should encourage an upslope flow regime here across southeastern Wyoming and into Colorado. And there are some things I'm noticing that are a few red flags. This is going to be like a post-frontal regime set up. You can see we have a cold front that goes through. You see these northerly winds. It's a rather weak cold front, but I'll show you here in a second. It sweeps out a little bit of that moisture. So that's a little bit of a concern. We should get those winds to start turning easterly, and that should help with that upslope flow regime. But I think that's going to happen. It's going to depend on when that happens, and it may happen later in the day. And I'm noticing some signal from cams that are initiating storms past 8 p.m., maybe even 10 p.m., maybe even midnight. So this could be a relatively later chase, depending on when these winds flip easterly and start that upslope flow. So we'll see. You can see here, our storms are going to initiate around here towards Chugwater on that Chugwater cyclone. So you see with this post-frontal regime, before that cold front comes through, this is early in the morning, around 8 a.m. You can see these dew points in our area of interest where these storms are at least going to start off. We got high 50s dew points there, maybe even 60s creeping into southeastern Wyoming near Chugwater. And as the day progresses, you can see these northerly winds. This is our weak cold front, and that's going to actually reduce our moisture values. We're going to end up in the low 50s. This is perhaps maybe even due to overmixing as well, but it's a combination of maybe some overmixing and that post-frontal regime. But we should get these winds to start to flip easterly, and the earlier that happens, the better, because that will pump that. You can see that moisture starts to increase as these come from the east and southeast, and that should start to pump more moisture in. But that's just the concern, is when is that going to happen? Because we need those easterly winds for the upslope flow regime to spark storms, and I'll show you that here with the SIMREF. So SIMREF shows this, or excuse me, ACRRR shows the same thing as RAP, that post-frontal regime. And if we go to SIMREF here, all right, you can see this is the latest run, at least 0Z run. And we have some storms here across Wyoming come through, and those initiate. So there's one storm that initiates up here with that upslope flow regime. And then near that Chugwater cyclone, we have a couple more supercells that may manifest and move southeast. So this is a viable target for storm chasers. It's just going to depend on how late that happens, and very similar story here towards Denver. You can see this is actually where most of our tornado risk is right now across eastern Colorado. Same setup, upslope flow regime there near east of Denver. And you can see HRRR really doesn't kick it much off. We may have some attempts here that struggle, but we don't really get robust signals, the updraft Felicity signals, until after 12 a.m., which is rather interesting. If you're into lightning, that could be a lot of fun. These nighttime lightning shows out here in Colorado are a blast. But yeah, it's just really going to depend on how quickly we flip to easterly surface winds in that post-frontal regime. So that's something to watch for. But we will have an all hazards threat out here, mainly a large hail threat, but it could be a structure day. We'll take a sounding here ahead of these Wyoming supercells. Perhaps some elevated supercells with these. Your wind profiles, all they have to really be in this area is sufficient for supercells. You're more thermodynamically driven out here. And this is certainly a wind profile that's sufficient for supercells. You see this post-frontal regime, you got these northeasterly winds at the surface. It may be hard to get tornadoes without a boundary, and that's obviously going to really depend on our low-level lapse rates, and it doesn't look like we're going to have all that much instability. So I'm not too sold. It could be more of a structure day. And of course, down here in Colorado is going to be perhaps a little better. This is where our main risk area is. We'll take a sounding here near Limon. And you can see much better instability profiles with any supercells that develop here. You don't need a lot, again, with these low-level wind profiles. All you need is enough bulk shear. We've got 0 to 6 shear, 59, almost 60 knots. So that's plenty for supercells. And these thermodynamic profiles are impressive. Upper 50s dew points. We may have higher dew points down here in Colorado than up there near Chugwater. So I think perhaps eastern Colorado is a better target than up there for storm chasing. So yeah, this looks good for perhaps an all hazards, low end tornado risk. But yeah, it looks like a fun chase day over there in Colorado.
Great analysis, Stephen. Let's move farther north now. Talk a little bit about this threat that has been slowly but surely coming into focus along the eastern North Dakota and western Minnesota border, right around Fargo. What are we expecting up there? I know that wasn't a lot of stuff on the social medias, Discord, Twitter about that earlier in the day, but it seems like it's definitely increasing in potential.
Now, I really do this target. I think it could be a lot of fun. The tornado risk is very low. I know there's a few storm chasers making the haul up there, or at least that are in the area that are going up here because it looks good. So we have this positively tilted trough that is going to swing through the area. That's going to bring around 35 to maybe 40 knots of flow through the area here. And the main time frame for tornadic supercells is I'm gonna say around 6 to 8 p.m. is when I'm looking. So I will say the very first thing I want to kick off by saying is today is in this region, the thing you want to look for is your low-level lapse rate. So that's going to be driving any tornado protection, because if we take a look at our 850 millibar winds, our low-level jet, not very strong. This is well removed from the area of interest here. And so 6 to 8 p.m., not a lot, only about 10 to 15 knots of flow here. So these are not going to be shear driven, these tornadic supercells. These are mainly going to be thermodynamically driven. And we really want to look for any ounce of sunlight. And if we take a look here, and this is RAP, there's a lot of models you can use to look at cloud cover. We'll just take a look at RAP. So you can see we have a lot of cloud cover there early on in the day, but it should start to clear, perhaps some breaks by around 3 to 4 p.m. But my main area of interest is going to be here from Ada to Fargo to Monoman, I think is how you pronounce it. Yeah, Monoman. And if we look at our low-level lapse rates, I don't believe that that Weatherfront has the low-level lapse rates product. So we're going to look at Pivotal really quickly. You can see our low-level lapse rates are going to be highest. Let me go to 0Z. Our low-level lapse rates are going to be highest basically east of Fargo. I would say target lapse rates above 8. Just go to wherever you get the most sun. You want to target these lapse rates above 8 because you want that maximum stretching. I'll take a sounding because I don't believe I've done that yet. So we'll go ahead and take a sounding in this region. We should have a nice tongue of 60 dews that stream upwards into this area. So we'll take a sounding at 6 p.m. around Ada or Ada. And you can see stick straight Hodographs, not a lot of low-level shear, but these lapse rates, 8 degrees Celsius per kilometer. That's very impressive. This is like a pseudo cold core setup. You can see these. We're so close to that 500 millibar low. These 500 millibar temperatures are very cold relative to further south across these other risk areas. So it's like a pseudo cold core setup. We'll have a surface low. The surface low is a little bit far. It's going to be over here, perhaps in northern North Dakota into Canada, and it should migrate towards Minnesota later in the day. So it's a pseudo cold core setup, but play it like it's a cold core. Target those lapse rates, target that surface vorticity. I think SPC mentioned a 2% risk upgrade here if those lapse rates, those confidence in those lapse rates and the heating, diurnal heating uptrend. I think a 2% is definitely possible out here. We could see a brief tornado or two. Otherwise, it's mainly just a large hail day up here. So you can see early on in the day, we're going to have a lot of convection there, but that should clear out of our main risk area by around 12 p.m., 11 to 12. And you can see we have a couple of popcorny showers go up early on in the day, because I said the main time I'm looking for is going to be around 6 to 8 p.m. You can see we have a lot more stuff pop up. So go wherever this morning and afternoon convection does not ruin your low-level lapse rates. That's going to be the biggest thing. Look for those low-level lapse rates. Look for that stretching potential. And that's going to be here in Ada, Foston, Fertile, Thief River Falls, perhaps in this triangle here. And this terrain is really good. I was honestly talking about this with my friend. I think we could get, I guess you could call it a terrain influence. I think these fields will heat up faster than the forest. So I think this could be a lot different if it sets up, say, over the forest, because these setups can always change. They could shift to the forest. And so I think this is setting up in a great area. Obviously, we love these fields for chasing, as you can see very far. But I think the fields also heat up faster. So that should help with recovery in those low-level lapse rates than if it were to say over here in the trees and the lakes. I think we're in a good spot for this setup thermodynamically and, of course, terrain chasing wise.
The Chaser Academy is the best deal in storm chasing, and it costs less than a combo meal at McDonald's. Unlock instant access to exclusive storm chasing presentations, participate in live group coaching sessions, and get answers to all of your questions in the unlimited Q&A chat. Whether you're a beginner, a veteran, or somewhere in between, our expert coaches will help you take your storm chasing experience to the next level. Click the join button below this video or on our profile page and enroll in the Chaser Academy right now. All right, Steven, we promised them a third target, and a third target we are going to give them. We're heading back down south to the Texas Panhandle, and this is the play that you and I were, I think, both the most excited about. Didn't really get much love in the earlier SPC outlooks, but things are definitely trending upwards, and if that EML can get broken through, I think any storms that could go up and sustain for a little while are going to have an incredible environment to work with.
Yeah, the environment should be one of the most favorite environments for storm chasing I've ever seen. Everybody loves this kind of environment, this kind of storm chasing setup, so we'll go over that right now. So we should have about 30 to maybe 40 knots of flow across our risk area. And that's going to, of course, be here in the northern Texas Panhandle, into the Oklahoma Panhandle, perhaps even western Oklahoma. And that's going to be circling around our ridge of high pressure over here in southwest Texas and northern Mexico. So a nice little belt of flow that should easily support supercells. All right, so we should have a nice ridge of Theta-E extending all the way up into even Colorado. That's very impressive. If we take a sounding here in, not that, if we take a sounding here in southeast Colorado, we'll see we should have lots of instability. That is beautiful. Although that moisture is on the low side, you can see these temps are very high there in Colorado. But that Theta-E tongue, that ridge of Theta-E is extending all the way up into southeast Colorado. But this if this isn't a look, this is fantastic. We've got perhaps this little bit of a surface low here. I got to see if that's an CV. I believe it's more of just a synoptic surface low as we get this flow to the Rockies. But that Theta-E ridge doesn't get any more classic than that, with that surface low curling it around. That is just beautiful.
Now, Theta-E, Stephen, I think that's something a lot of folks probably aren't too familiar with. What exactly is that measuring?
Yes, so Theta-E is a little bit different from dew point. It takes the dew point temperature and the regular temperature into account. It's basically just another form of showing how much energy you have in the atmosphere. So I'll do a circle of the Theta-E here, and you can see, excuse this horrible circle, but oof. I'm on a trackpad right now, so this is very difficult. But
yeah, I'm going to go ahead and say it. That's not anything close to a circle, but please go right ahead.
Something like that. So you can see here, that's going to line up with where our highest cape is. Basically, storms love these supercells. Tornadic supercells love this ridge, seeing these ridges of Theta-E. They love to ingest that Theta-E. So this is a very impressive ridge going up here. And I just love that look, how tight it gets right here around the surface low. This is where our area of interest is for storm initiation. And that's just the start of it. I got a lot I want to talk about this setup.
Definitely don't let me stop you, Steven. So which parameter should we head over to next?
Yeah. So I want to talk about the potential boundary. I think the cams are resolving this better. That's one of the issues the SBC mentioned for risk upgrade is cams are all handling this very differently. So if this is like a surface obs day if I've ever seen one, it's just going to be wake up and see what is happening, because this could be an absolute nothing burger or one of the like tornado of the year potential, violent tornado potential. I think if a boundary day, you can always get those really thermodynamically boundary driven tornadoes that can be rather violent. We saw one today in Southwest Texas near Fort Stockton. There was a 0% tornado risk there, and we had a pretty violent hybrid tornado. And I say violent because the atmosphere was rather dry at the surface, and it allowed for very high cloud bases. And the drier it is, the higher clouds are, and the harder it is to condense a funnel. So using some math, I saw my friend do it. It would take very high wind speeds, probably above EF4, to condense a funnel in that environment. So we had that today in a 0% tornado risk over here near Fort Stockton. It was a beautiful tube, and I think a rancher and a sheriff saw it, and that was about it. So no chasers were on this. So I think similar boundary potential. I think it looks really good, and I'll show you that boundary now. So again, there's just a lot of spread in cams, even run to run between the same cam. It's all over the place. Let's take a look at what our 18C run today said. We should have a lot of stuff going through in the morning, and it's TBD if this is an MCS or supercells early on in the day. We'll see. 18Z had more supercells, but this is the main stuff that we want to talk about right here. Is this stuff initiating here in perhaps southern Kansas through the Oklahoma Panhandle into the Texas Panhandle? If we see has much more of an MCS moving through. So it's a toss up. What are we going to see? This is why they've held off on the tornado potential, because it's very boundary driven. It's very localized, very mesoscale. So we should have this MCV, and that could lay a boundary, a very interesting boundary. So you can see that MCV moves through early on in the morning through the afternoon. You can see that boundary gets laid. We get very quick atmospheric recovery. Those dews skyrocket back up to the 70s. And so that boundary is going to be oriented somewhat like this. And that's great for the storm motions that we're going to be seeing. And you can see it perhaps migrates north with those southerly winds. It's just going to really depend on where this boundary sets up. But this model run has it set up right there. You can see that dew point difference. If we look at the temperature difference is also there. You can see that boundary right there. And if we look at our STP values as well, you can also see that boundary right there. And if we can get a supercell to initiate and track right on that, which is very possible near Perryton, Canadian, Texas, and Southwest Oklahoma, I think we could have photogenic tornado potential. Otherwise, if that doesn't happen, the environment will still be very supportive of photogenic supercells. I do want to talk about our low-level jet. So that's going to be rather weak throughout the day, but that's going to actually considerably increase. You can see that low-level cyclone becomes really defined. Look at that at 12 a.m. That is a beautiful look. 40-knot low-level jet over there, but that's a little bit late. So we want to go to when we're most interested in these storms, and that's going to be around, we'll say, the 7 to 8 p.m. time frame. And that is still rather good. That's a 35-knot low-level jet. We'll go there near Perryton. And you can see massive cape, over 5,000 joules per kilogram mixed layer cape. That is fantastic. And these wind profiles are probably the most classic wind profiles for just photogenic structure fest. You can see you got this crosswise 0 to 500 meter with immense streamwise vorticity above that. That is a recipe for structure fest, these types of Hodographs. Just a little bit of crosswise at the surface with massive looping streamwise Hodographs above that. Ample dry air. I noticed one of the AFDs in one of the areas, I think it was Amarillo, was talking about the potential for dry air entrainment, and that would be a failure mode for any of these trying to pop up. But I don't think this isn't the most dry air I've ever seen. I think we've seen a lot worse. This is for sure manageable. It's a little dry at the surface, but that moist layer is very consistently deep up to around 500 millibars before we get really dry again. So I don't think dry air entrainment should be the biggest issue. I think we get some supercells, some structure. It's just that tornado potential is going to be really to be determined with that boundary, and that's going to be really relayed by what cams are saying. So we'll see what rapid refresh says really quickly as well. But you can see the STP here based on RAP is 11 with this profile. So if anything can get chugging along that boundary, my goodness, that would be incredible. I know everybody hates this model, but we're going to take a look at what it says. Look at what Rufus has for Colorado, and it's on track with the HRRR in terms of timing. You can see we don't even get a supercell to pop near Denver until 8 p.m., which is rather late, and that continues southeastward where we get more supercells, perhaps a windy squall line. And same up here in Wyoming. We may have some stuff initiate over here in the really low moisture and make its way over. So I don't know. It's rather interesting to see it's on track with HRRR, pretty close, and I just spun the entire planet.
Looks like we have some localized vorticity happening on your computer.
Yeah, that was actually a part of the plan. Everybody get to Colorado now. I just added some vorticity. We'll look at here is Minnesota, and Rufus has a lot of supercells going through. Early one, perhaps near Fargo, but the main show is going to be 6 to 8 p.m., perhaps near Fargo and north. This does have me intrigued, so interesting to see Rufus showing that signal there. Sometimes it'll have a little signal. It doesn't hurt to take a look, and obviously ignore pretty much if Rufus puts out 10 supercells, expect one. You can see it just puts a load of convection, but perhaps for positioning, we could get some stuff here in Southwest Oklahoma. Those ones that train along your boundary are going to be the ones to look at, and let's see if it has that early morning convection. And it really doesn't. It doesn't have any MCS, any supercells that move on early through the day. So I don't know. Rufus is an outlier there with perhaps even a boundary occurring. But now looking at dew points, I want to go back and lastly talk about a potential fail mode. And this is very common out here. We may have more of a dual dry line. So if we look, this is around 4 p.m. Storms may initiate 5, 6. You can see here, we've got 2 separate dry lines, maybe even 3 if we're considering this out here, but I think they're more likely to initiate here. But we've got these dual dry lines here, and that's a bit of a concern. You never really want to see that. You want a tighter gradient with your dry line, and why that is that you may initiate storms on the, let's look at cams. We may initiate storms, and ARRR has it a little differently there. Actually, no, rather similar. I was at the wrong time, but you can see we may initiate these storms here towards Amarillo in the dry air. You can see that air here is relatively dry. We're in 50s dews. We don't want that here in the Panhandle. We want to initiate in upper 60s and 70s dews. So these would likely be outflow dominant hail and wind producers there. And you can see they conglomerate into a bit of a line there. They go outflow dominant rather quickly. This is what we're going to be looking for up here, is this to initiate in our 70s dews, perhaps near Perryton into the Oklahoma Panhandle. We want to initiate in these higher dew points along this boundary, of course. So that's going to be a fail mode if we get stuff to initiate in the lower dews. But I don't think it should be too much of an issue closer to this low. That low, you can see, really tightens. Let me get rid of these lines. Really tightens that gradient there, and it really tightens the dew points further north. So you see how tight that is there. We could initiate a storm here right next to that low along that boundary. So I don't think it'll be too much of a concern up here. Just further south, if you're planning on chasing Amarillo, that could be a concern, but we'll see how that plays out. It's going to be a very surface obs heavy day. The fact that they don't even have a 2% out.
I just want to say also that we are recording this right now about 45 minutes or so before the day one outlooks actually come out. So decent chance that some of these probabilities we're talking about, like a 2% tornado risk not being in the area, all that jazz, might be different when you actually watch this video. So just keep that in mind. And Stephen, I think you wanted to play us out by checking out a couple of the companion tools that you use. StormNet being one of them and NATOCast being another one. So go ahead and let us know what you're seeing there.
Yeah. So StormNet has an absolutely fantastic track record at medium range. We saw it with this event the other day or yesterday, the Illinois event. It absolutely nailed that. It nails so much stuff at medium to long range. It's incredible. But we'll take a look at what it has. So we'll start where we started off here in Colorado. And so this is Tuesday at 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. And you can see around 7 to 8, those tornado probabilities increase, probably northeast of Pueblo, southeast of Denver, right here. And so that's going to be translating southeastward as these supercells move east, southeast into southeast Colorado. And we'll take a look again up here in northern Minnesota near Fargo. Low probabilities as well up here, but not zero. It's just a very mesoscale risk kind of day, not really synoptically driven tornado risk. So you can see a little bit of a signal up here, this little lobe just to the west of Bemidji. And then finally, we'll look down here near the Panhandle, and there isn't much of a signal, really. This is, again, going to really depend on that boundary placement, but there is perhaps a small signal, but not much, really not much. So that has me a little bit concerned because StormNet is really good. Even with sneaky days, I've noticed it's rather good. So that has me a little concerned, but I think it has a lot of potential here. All right, we'll look at NATOCast now. All right, in the NATOCast, there's obviously another target over here on the East Coast. If you're an East Coast chaser, nobody really cares about the East Coast, so we're not going to go over that. But there is perhaps a little bit of a target over there. NATOCast really, oddly enough, really likes that Minnesota play. It has a 5% up there, a large 5%. So that's interesting to see. And of course, this risk over here in Colorado and a little 3% there. NATOCast is really good with these low end days. It may be picking up on that boundary position right there in the northern Panhandle. So that's rather interesting to see.
Yeah, and I guess before we bounce out of here, Stephen, we should probably give the devil its due. If you do happen to be on the East Coast and you decide you absolutely want to see some storms, then just go ahead and position yourself wherever it seems advantageous along that coastal plain, and hopefully you can get something that will be playing off of that MCV that's supposed to roll through the area pretty early in the day.
Yeah, I haven't even looked at the setup, but I did see mention of that MCV. Let's see. And they do, I thought I saw a tornado risk there. No, I did not. But there may be a low tornado risk, of course,
They did
according to
mention
NATOCast.
in the day two outlook that they are, I believe, in one of the AFDs that came out from the local area, that they may bump that up to a higher probability, just depending on
Yeah.
the details that come into focus.
Yeah, I wouldn't be surprised. We'll go ahead and take one sounding, talk about that real quick. Let's take one ahead of these storms at around 2 p.m. We'll just take a look at what it looks like just for fun. And yeah, very steep, 9 degrees Celsius per kilometer low level lapse rate. So that's very impressive for the eastern seaboard. Ample Cape, 1,400 joules per kilogram. Decent mid-level lapse rates. Not the best, but decent. And that's not really going to do much. Maybe you could get some East Coast magic or something, but that's not a very impressive wind profile for maybe some transient supercells, but that tornado potential is very low with that low level. There's not going to be much of a low level jet out here. Perhaps further south into North Carolina at 4 p.m. Like you said, there's going to be a remnant MCV, I believe. I don't know exactly where that is supposed to set up. Let's see if we can see it. It's a little hard to pinpoint. Oh, yeah, there we go. Perhaps a little bit of a low, maybe an MCV here. So that could help to back those low level winds and get a little bit more wind shear.
Stephen, before I let you go here, do you ever get sea breezes interacting, like outflow boundaries in these
Yeah.
sorts of setups?
Yeah, I don't forecast that stuff that much. I know it's very common in Florida. I don't know how it is up here, but that may be, you could get some sea breeze outflow boundaries that you could definitely get some funkiness over here. So maybe play the beach, maybe go see some water spouts. I think water spouts are very easy to spin up in these types of setups. So honestly, if I was there, look at that. We have a supercell or U-track signal here just along the coast. We'll take a sounding there. And that could produce a water spout. You never know. So I would water spout chasing, if anything, if I was over here.
Yeah, you get a nice little sea breeze boundary or something to increase that low level wind shear, and boom, that's a Tornadic Hodograph right there.
Exactly.
All right, is that a wrap?
That's a wrap.
It's definitely not a NAM.
I see. It's pretty good.
Remember to check out those links in the description below, and then watch another video.